So the next question that we have here is 2 plus 4 plus 8 plus dot 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 plus 2 to the power n is equal to 2 open brackets 2 to the power n minus 1 there. So here we prove this statement using mathematical induction. So step number 1, we need to show that this is true for n equals to 1 here. So we just put a statement down there. So we need to show that this is true for n equals to 1 there, or when n is equals to 1. So now we just get 2 to the power n, we equate it to the right hand side this side. So we have 2 the power n here is equals to 2 open brackets 2 to the power n minus 1 like this here. So then where there's n here, we're going to put 1. We substitute with 1 there, so we have 2 the power 1 is equals to 2 open brackets 2 to the power 1 minus 1. So here 2 to the power 1 is just basically 2 there, equal to 2 open brackets 2 minus 1. So here we have 2 here is equals to 2 multiplied by 1 this side, then we have 2 is equals to 2 there. So here this shows that this statement that we have here is true for n equals to 1 because we've gotten the first term of the series or sequences that we have there. So it says therefore true for n equals to 1 there. Then we'll go to step number 2. So step number 2 is the inductive hypothesis. So inductive hypothesis. So on the inductive hypothesis, we make an assumption where we assume that the statement is true when n is equals to k there. So we assume that it's true for n equal to k, or when n is equals to k rather. So here we have 2 plus 4 plus 8 plus 2 to the power k here equal to 2 open brackets 2 to the power k minus 1 like this here. So under the inductive hypothesis, you only make a substitution where there's n, you put k there. So we'll go to the third step now. We need to show that it's also true here when n is equals to k plus 1 this side here. So meaning that to the terms that we have there, we add a new term which is the ak plus 1 term. So meaning that on the right hand side there's a term that we're going to add there. So here we're saying we have our 2 plus 4 plus 8 plus 2 to the power k here. Then we add the new term now, 2 to the power k plus 1 equal to 2 open brackets 2 to the power k plus 1 minus 1 like this here. So here our goal is to show that the left hand side is equal to the right hand side. So then when you look at these terms here, starting from the first term up to the k term that we have here, you notice to say that they give you an expression that we got on the inductive hypothesis. So we just make a substitution with the expression that we have on the right side of the inductive hypothesis there. So we have 2 open brackets 2 to the power k. Just erase that. So we have 2 to the power k minus 1 like this here, plus 2 to the power k plus 1. So this here is equals to 2, open brackets, we have 2 to the power k plus 1 minus 1 like this here. So now here, if you multiply this term here by this term here, we're going to get 2. So here we're saying if you multiply this term here by the 2 that we have here, we're going to have 2 multiplied by 2 to the power k minus 2 there, plus this term here is just basically 2 here multiplied by 2 to the power k like this here. So this here is equal to 2 this side to the power 2 multiplied by 2. Okay, so let's just say k plus 1 this side minus 2 like this here. So now here, when we add this term and this term together, because they have 2 to the power k as a variable that we have there, so we're going to have 4 2 to the power k minus 2 is equal to, then this side here, okay, let's factor out the 2 again, so we can just factor out the 2 there, we leave it the way it is here, minus 1 like this here. So now here, you notice to say that this 4 here can be found by multiplying 2 by 2 there. So then here, if we say this is 4, this is 2 multiplied by 2 multiplied by 2 to the power k here minus 2 like this, we equate it to 2 to the power k plus 1 minus 1 like this here. So 2 multiplied by 2 to the power k is the same as 2 to the power k plus 1, because the power that we have here is 1 here, so meaning that if the base is the same, we add the powers that we have there. So we have a 2 here multiplied by 2 the power k plus 1 minus 2 equal to 2 open brackets 2 the power k plus 1 minus 1 like this here. So then here we can just factor out the 2 because it's common on the 2 terms that we have. So we have a 2 open brackets 2 to the power k plus 1 minus 1 is equal to 2 open brackets 2 to the power k plus 1 minus 1 like this here. So now, looking at what we have here, the left hand side is equal to the right hand side here, and what we've done here is we've shown to say that sk plus ak plus 1th term is equal to sk plus 1 like this here. So therefore we say this is true for n equal to k plus 1. So if this is true for n equals to k plus 1, then this holds under mathematical induction. For every natural number in there. Okay, let's go to the next question.